All right, we're going to do the first free response from review day 1. We have a graph of f, and then we're told g is the integral of f. Right away when we see something like this, we have to have in our head that g prime, the derivative of g, would be the derivative of this integral, which cancels and gives us just f. In other words, this is the derivative of g, and how we should think about it as we go. That's going to help with parts B, C, and D. A was the toughest of the 4 parts. It said find the average rate of change of g from -5 to 5. The setup is easy enough. We know an average rate of change is how did g change from start to finish, and how long did it take for that change to occur. So this quotient right here should not have been hard. In fact, if you wrote that on your paper, you got 1 point for that. Okay, but the problem is figuring out what g of 5 and g of -5 are, because we have to figure them out as the accumulated area from 1 to whatever. So kind of using 1 as our starting point here, what I'm going to do is just kind of find these areas. So I see that this triangle here is height 4, base 2. 4 times 2 divided by 2 is 4. Then I've got this rectangle that has an area of 8. Then I've got this little rectangle, or this little triangle here, height 2, base 1. That's an area of 1. We've got this quarter circle, radius 2, so pi times 2 squared, 4 pi. We want 1/4 of it, so this is just pi. And then we're going to go all the way out to -5 here, so this is a triangle, 1, 2, 3, 1, 2, 3, 4. 3 times 4 divided by 2 would give us 6. So I'm finding these areas here, and now let's use them to find out what these values are. So g of 5 is the area from 1 to 5. From 1 to 5, that area is 12. Okay. Minus, now we want the area from 1 to -5. So all of these areas are negative. It's 7 plus pi, but they're all negative, but we are going backwards. So it's actually going to be 7 plus pi positive there, divided by 5 minus -5, which is 10, which will give us 5 minus pi divided by 10. Okay. Now that final answer they gave 2 points for. I'm assuming they'd give 1 point maybe for these areas, maybe this one, or something like that. If you showed a little bit of understanding of what g of 5 and g of -5 were, then you could get them. And then 1 point for the final answer here. So 3 points total here, 1 for the setup, 2 points for getting to here. Okay. Then B says find the instantaneous rate of change of g with respect to x at 3, or state it doesn't exist. So instantaneous rate of change, that's just the derivative. They want to know what g prime of 3 is. And we've already said that g prime is f. So g prime of 3 is f of 3. And if you come up here at 3, f of 3 was 4. And you got 1 point for that. Okay, so not too bad. On what open intervals, if any, is the graph of g concave up? So a function will be concave up when its second derivative is positive, but really for us, we're going to talk about the other case, and a function is concave up when its derivative, which is f, is increasing. And this is f right here, and it's increasing from -5 to -2. So from -5 to -2. And then again from 0 to 3. All right. So you got a point for having the intervals, and then if you said that that's where g prime of x, which equals f of x, is increasing, then you got another point for that. All right. And then the last one says find all the x values between here where g has a critical point. So we know a critical point is where g prime, which is f, equals 0. Okay, so we look at our graph, and we see that it equals 0 at -2 and at 1. So at x equal -2 and at x equal 1. Okay, so if you had if you said this, you got a point. And then if you had these values, you got a point. Okay, now we have to make a decision about what's going on here. So at -2, the derivative goes from negative and stays negative. So -2 is neither. G prime of x is negative before and after x equal -2. Okay, and then at 1, we go from negative to positive. The derivative is going from negative to positive. So anytime the derivative goes from negative to positive, that means our function is going from decreasing to increasing, so we have a relative minimum there. All right, and we would say relative minimum because that's where g prime of x switches from negative to positive. All right, and if you had both of those with the right justification, another point. So 1 point for this setup here, 2 points for the answer, 1 point for this derivative, 1 point for these intervals, 1 point for the explanation, 1 point for saying that g prime of x has to equal 0, 1 point for finding those values, and then another point for the justification. 9 points total. How many did you get?